Good day, everyone. Welcome in physical science. Before we start, we'll be having a pre-test. So choose the letter of the best answer in each item and write it on a separate sheet of paper. Number one, forces that are present between among molecules. A. Ionic. B. Covalent. C. Intermolecular. Letter D. Intramolecular. So the answer is letter C. Number two, forces that are present between an ion and a polar molecule. A. Ion dipole. B. Dipole dipole. C. Dispersion forces. Letter D. Hydrogen bonding. The answer is letter A. 3. The ease with which the electron distribution in the atom or molecule can be distorted. A. Diffusion. B. Polarizability. C. Dipole moment. D. Induced dipole. The answer is letter B. 4. Attractive forces that arise as a result of temporary dipoles induced in atoms or molecules. A. Dipole forces. B. Induced dipole. C. Dispersion forces. D. Instantaneous dipole. The answer is letter D. 5. An interaction between the hydrogen atom in a polar bond and an electronegative atom such as oxygen, nitrogen, or fluorine. A. H bonding. B. Dipole dipole. C. London forces. LRD. Ion induced dipole. So the answer is letter A. 6. The strongest among the intermolecular forces of attraction. A. Ion dipole. B. H bonding. C. Dipole dipole. D. Dipole induced dipole. So the answer is letter A. 7. Attractive forces between polar molecules, where the positive end of one molecule aligns to the negative end of another molecule. A. Ion dipole. B. Dipole dipole. C. Dispersion forces. Letter D. Ion induced dipole. The answer is letter B. 8. It results when an ion or polar molecule is placed near an atom or a nonpolar molecule, such that the electron distribution is distorted by the force exerted by the said substances. A. Hydrogen bonding. B. Ion dipole forces. C. Dispersion forces. D. Dipole-dipole interaction. So the answer is letter C. 9. The strength of London dispersion forces is a function of the molar mass of a substance. As the molar mass increases, the strength of the interaction between the molecules due to dispersion forces. A. Increase. B. Decrease. C. Remain the same. D. Cannot be measured. The answer is letter A. 10. A heat of hydration is the result of favorable interaction between the cations and anions of an ionic compound with water. The nature of this attraction is A. Hydrogen bonding. B. Ion dipole forces. C. Dispersion forces. D. Dipole-dipole interaction. The answer is letter D. 11. The measure of the shift of the electron density towards the atom with a higher electronegativity value. A. Polarity. B. Polarizability. C. Dipole moment. D. Forces of interaction. The answer is letter C. 12. The strength of ion-dipole interaction depends on the ions present. With ions of the same magnitude, which is true about this interaction. A. Cations interact more strongly than anions because their charges are less concentrated. B. Cations interact with more strongly than anions because of their charges are more concentrated. C. Anions interact with more strongly than anions because their charges are less concentrated. Letter D. Anions interact more strongly than anions because their charges are more concentrated. The answer is letter B. 13. At any point of time, the shift in the positions of the electrons in an atom will likely create a temporary positive and negative poles known as A. Dipole forces, B. Dipole-dipole moment, C. Dispersion forces, D. Instantaneous dipole. The answer is letter D. 14. the forces or the force of attraction present between the species iodine gas and we have NaO3 or ammonia. A. London dispersion forces. B. Hydrogen bonding and ion-induced dipole interaction. C. Van der Waals interaction and dipole-dipole interaction. C. London dispersion forces and ion-induced dipole interaction. So that is letter B. 14 is letter D. 15. Which of the following substances contain molecules that are capable of forming hydrogen bond among themselves? A. Ethane. B. Acetic acid. C. Beryllium hydride. Letter D. Potassium fluoride. So that is letter B. Now, our topic for today is the types of intermolecular forces. For our objectives, number one, describe the types of intermolecular forces present in substance. Two, identify the types of intermolecular forces present between and among substances. Atoms in molecules and ionic substance are attracted to each other either by sharing or complete transfer of electrons. These attractive forces keep the molecules intact. But how do molecules or substances stay together and exhibit properties that are unique to them? This is known as bulk properties. In this lesson, you will learn how the different forces of attraction known as intermolecular forces keep substances together. You will also be able to identify the intermolecular forces present between and among substances. Thus, their bulk properties can be predicted. This simple activity will help you recall what you understood about Lewis' electron dot structure and polarity of molecules. The polarity of substances will guide you in identifying the intermolecular forces present between and among molecules. So first, we're going to discuss with you the molecular shapes. So here are the shapes class and molecular shape and for examples. For example, we have shape class AX2. Okay, so we have molecular shape, we have here, and examples. For examples, we have beryllium fluoride. So we have here. So the central atom must be beryllium, and the two atoms here is fluorine. So fluorine has seven dots, while beryllium is two dots. So we have here one shared to fluorine, another one, okay, will share to another fluorine. So therefore, the Lewis structure of fluorine is eight dots and also eight dots. So it's complete. This molecular shape is what we call linear. Another molecular shape is trigonal planar. So we have shape class is AX3. For example, is SO3. So we'll be having here. S is the central atom, and we have three oxygen here. So we have 8, 8, and 8. All right. So another one is the bent or V shape. So just here, the AX2E. Okay, so we have lone pair here. So for example, SO2. So we have the S here and oxygen, another oxygen, and we have lone pairs here. Another one we have AX4, and for example, we have methane, CH4. So we'll be having here, so C, and we have four hydrogen. So this is what we call tetrahedral. Another one is ammonia, NH3. So therefore, we have here uh, N as a central atom and three hydrogen, and we have here lone pairs. And this molecular shape is trigonal pyramidal. Another one is AX2E2. So meaning we have two lone pairs. E stands for the lone pairs. Uh, for example, water. So we have here, all right. So we have oxygen and two hydrogen, and we have lone pairs of one, okay, and two. So we have four. And this molecular shape are what we call bent. Another one is AX, all right? So 5 molecular shape, for example, is PF5. So we have central atom of P, and we have fluorine 1, 2, 3, 4, 5. And this molecular shape is trigonal pyramidal. Another one is AX4E. So we have lone pairs. Okay. Example is SF4. So we'll be having central atom S, and how many fluorine? 4. So 1, 2, 3, 4. And we have lone pairs of 2 dots. Okay. Another one is AX3E2. So therefore we have 2 pairs, lone pairs. So for examples, chlorine F3. So we'll be having here central atom is chlorine, and fluorine, 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 and we have here E. Okay, 2 lone pairs, and molecular shape is T shape. Another one is AX2E3. So we'll be having, for example, is I3. So we'll be having I, then I, and I. So we have 3 lone pairs. So 1, 2, and 3. Another one is AX6. So we have here, example is SF6. So we'll know center atom is S, and we have 6 fluorine, 1, 2, 3, 4, 5, 6. And this shape is octahedral. Another one is AX5E. So for example, is IF5. So the central atom is iodine. So we have fluorine, 1, 2, 3, 4, 5. And we have lone pairs here. Another one is AX4E2. So we have 2 lone pairs. So I'll be having example is XeF4. So here the central atom is Xe, and we have 4 fluorine, 1, 2, 3, 4, and we have 2 lone pairs. And this is what goes square planar. Now for your activity, okay, for example, polarity of molecules based on the LEDS. So we have Lewis electron dot symbol. For example, substance. So we have freon, or the CCl2F2, freon 12. So the LEDS, okay, we have here the central atom is carbon, and we have 2 fluorine and 2 chlorine. So 8, 8, 8, and 8. So the shape is tetrahedral, and this is polar. Okay, are you ready? So, directions of your activity. Number one, use a clean sheet of paper to answer this part. Number two, copy the table and fill up with the correct information. And three, show the direction of the dipole moment for each molecule. So here we have our substance, we have the LEDS, or we have the Lewis electron dot symbol, the shape, and polarity. All right. Now, let's answer the activity. So, polarity of molecules based on the LED. So, this is the answer. We have freon 12, and this is the Lewis electron dot symbol. Okay, the shape is tetrahedral, and it's polar. Nitrogen gas, and this is the LEDs. Its shape is linear and non-polar. We have the methane, so the LEDs is here, and the shape is tetrahedral. It's non-polar. Another one is water, so the LEDs, the shape is bent, and polarity is non-polar. Carbon monoxide, so the LEDs here, linear and polar. So we have the types of intermolecular forces. Bonding forces such as ionic, covalent, and metallic bonds are classified as intramolecular forces, forces that hold atoms together in a particle. Okay, and particle has a molecule or formula unit, or in a piece of metal. In contrast, intermolecular forces are forces that hold particles, and these particles are molecules or formula units together. The stability of a molecule is attributed to intramolecular forces, whereas condense of state of matter, which is liquid and solid, and the properties such as melting point and boiling point are attributed to intermolecular forces. Intramolecular forces are relatively much stronger than intermolecular forces. Among the intramolecular forces, the ionic bond is relatively the strongest, while the metallic bond is the weakest. The following are the types of intermolecular forces. So we have here the dipole-dipole forces. So dipole-dipole forces is the result when an ionic compound dissolves okay, in polar solvent. Second, we have dipole-dipole forces. So it is produced when positive pole of one molecule is attracted to negative pole of another molecule. Three, hydrogen bond. So it is a force between polar molecules having an hydrogen atom bonded to a highly electronegative atom with lone electron pairs. Four, ion-induced dipole forces. So it is a result when the charge of an ion distorts the electron cloud of a nonpolar molecule. 5. Induced dipole forces, partial charges of polar molecule, may cause a distortion of the electron cloud of the nearby nonpolar molecule, creating temporarily partial charges of a nonpolar molecule. Another one is dispersion or London forces. So these forces produce when temporary dipoles are induced in a nonpolar molecules. So we'll be having here an activity to identify the intermolecular forces present among the following species. So we have letter A, letter B, letter C, D, E, and F. All right, for answers, for letter A, the answer is ion dipole forces. So it is a result when an ionic compound dissolves in a polar solvent. So here, this is a typical example of ionic compound that dissolves in water. So the sodium chloride, when sodium chloride dissolves in water, the ions of sodium chloride become separated. So sodium chloride is composed of sodium and chlorine. So sodium is positive and chlorine is negative. So it becomes separated and are attracted to oppositely charged poles of water. So therefore, here water here is polar or a dipole. So therefore, the sodium will attach to oxygen. Another one is for letter B. The answer is dipole-dipole forces. So it is produced when positive pole of one molecule is attractive to a negative pole of another molecule. The greater the dipole moment, the greater is the dipole-dipole force between molecules. Hence, the more energy it will take to separate them. So, a polar liquid having stronger dipole-dipole forces has a higher boiling point than the one with weaker dipole-dipole forces, just like fluorine and bromine. Now for letter C, the answer is hydrogen bond. So it is a force between polar molecules having an hydrogen atom bonded to a highly electronegative atom with lone electron pairs. So this atom could be nitrogen, oxygen, or fluorine. Compounds in which the molecules are held by hydrogen bonds have relatively high boiling points because hydrogen bonds are difficult to break. Therefore, letter C is hydrogen bands. For letter D, the answer is ion-induced dipole forces. So it is a result when the charge of an atom distorts the electron cloud. So the imaginary rapidly charging position of an electron or electrons around the nucleus of an atom of a non-polar molecule. This distortion result is a temporary induced dipole moment. An example of an induced dipole forces that binds iron in hemoglobin and oxygen gas molecule in the blood. So therefore, letter D is ion-induced dipole forces. Letter E answers dipole-induced dipole forces. So the partial charges of a polar molecule may cause the distortion of the electron cloud of a nearby nonpolar molecule, creating temporarily partial charges on the non-molecule. The force of attraction of one pole of the polar molecule with one of the poles of the nonpolar molecule having induced partial charges is called dipole-induced dipole forces. The solubility of oxygen gas in water is due to dipole-induced dipole force. So, the dipole-induced dipole force between water and oxygen gas. F, the answer is dispersion or London forces. So nonpolar molecules are in constant motion in a container, and their collision causes the distortion of electron cloud of a nonpolar molecule, thereby producing temporarily partial charges in a nonpolar molecule. Induced partial charges on the nonpolar molecule in turn causes the distortion of electron clouds of the neighboring nonpolar molecules. These forces produced when temporary dipoles are induced in a nonpolar molecules are called dispersion or London forces, named after Fritz London, the physicist who provided an interpretation for the existence of temporary dipoles. The condensed forms, solid and liquid, of a nonpolar molecules are attributed to the dispersion forces. Therefore, the dispersion force between the molecules of chlorine gas shows in letter F. Another activity, so we have here descriptions of intermolecular forces. Instruction, match column A with column B, choose the letters of the correct answer and write it on your answer sheet. So we have column A and we have column B. For our activity 2, we have intermolecular forces present among species. So identify the intermolecular forces present in the following species. So we have chlorine gas, carbon monoxide, sulfur dioxide, okay, dichloromethane, and dimethyl ether. Another one, what are general types of intermolecular forces? Two, describe the following in your own words. Van der Waals, dipole-dipole interaction, dipole-induced dipole interaction, dispersion forces, ion dipole interaction, and hydrogen bond. List down the intermolecular forces present in each species. A, hydrogen bromide. B, CS2, C2H6, D, CH3, COOH, letter A, BR2. Knowledge of concepts is not enough for a learning experience to be meaningful. We should also understand how the concepts we learn on the intermolecular forces can be applied to real life situation. To get the most out of what we've learned, let us look at a simple situation that will help us realize the advantage of the fully understanding intermolecular concepts. We have situation here. Storage of different substances at home needs careful attention. Alcohol, acetone, hairsprays, even gasoline should be taken care of to avoid fire. Where should these substances be stored? Why do we need extra precaution in keeping them at home? Relate your answer to the intermolecular forces. Now for our assessment, multiple choice. Choose the letter of the best answer and write the chosen letter on a separate sheet of paper. Number one, what is true about intermolecular forces? A, there are strong bonds that form between atoms or molecules. B, substances can form more than one, but one will predominate. C, they are stronger than the intermolecular forces between atoms. D, there is a vague relationship between intermolecular forces and bulk properties. 2. Ion-dipole interaction result from the A. Attraction between an ion and a polar molecule. B. Repulsion between a dipole and another dipole. C. Repulsion between a polar with another nonpolar molecule. D. Attraction between a polar with another polar molecule. 3. Why is the strength of interaction due to dispersion forces increases as the number of electrons increase? A. The electron distribution of big molecules is easily polarized. B. The nucleus in the molecules has greater effective shielding effect. C. The electrons more freely around the nucleus resulting to greater energy. D. The electrons in the molecules can easily jump from one orbital to another. 4. Which of the following sets of interactions are all van der Waals forces? A. Ion-induced dipole. Dipole-dipole, London dispersion forces. B. Dipole-dipole, dipole-induced dipole, London dispersion forces. C. London dispersion forces, ion-induced dipole, dipole-induced dipole. D. Dipole-induced dipole, ion-induced dipole, and London dispersion forces. 5. London dispersion forces are formed when A. There is instantaneous dipole that influence neighboring substances to gain dipoles. B. There is permanent negative and positive ends that participate in the electrostatic attraction. C. The electron cloud of the atoms is evenly distributed around the nucleus. D. The atoms of two neighboring molecules participate in give and take of electrons. 6. How does dipole-dipole interaction form? A. Polar molecules shift electron density that gives rise to neutral substances. B. The electron distribution in the polar molecules is distorted that results to negative and positive poles. C. Polarization of big nonpolar molecules causes the formations of permanent positive and negative charges. D. The positive and negative ends of one polar molecules align themselves to the positive and negative ends of another polar molecule and attract each other. 7. During ion-dipole interaction, the cation causes the A. Repulsion of charges among the molecules, B. Distortions of the electron distribution in the dipole, C. Attractions of the negative ion to the positive end of the permanent dipole, D. Formations of positive ions that are attractive to the permanent dipole. 8. Hydrogen bonding forms when the substances involved are polar and there are blank. A. Hydrogen atoms of molecule interact with oxygen, nitrogen, fluorine of other molecules. B. Carbon atoms attached to oxygen, nitrogen, and fluorine. C. Central atoms with oxygen, nitrogen, fluorine as attached atoms. D. Unshared pair of electrons in a central atom. 9. Which ions will result to higher ion-dipole interactions? A. Anions. B. Divalent. C. Cations. D. Monatomic. Next, what intramolecular forces are present between the molecules of the following substance? A. Methane. B. Acetic acid. 10. Methane. 11. Acetic acid. 12. Ozone. 13. Nitrogen gas. And we have 14. Ammonia. And 15. We have phosphorus pentachloride. Okay, for our answer, number 1 is letter C, 2C, 3A, 4B, 5A, 6D, 7C, 8A, 9C, 10. We have London dispersion forces. 11, we have London dispersion forces, dipole-dipole, and hydrogen bonding. 12, London dispersion forces, dipole-dipole. 13, London dispersion forces. 14, London dispersion forces, dipole-dipole, ion-dipole. And 15, dipole-induced dipole forces or London dispersion forces. Now for our additional activities, identify the intermolecular forces present in the following substances. Number 1, silicon tetrafluoride. 2, acetone. 3, methyl alcohol. 4, methane. 5, phosphorus trichloride.